Hello friends, the last portion of the fourth unit, we are going to solve the problem based on the tangential method. Before that, some disadvantages of the tangential method we will see. It lacks speed. How it lacks speed? Since we have to measure two vertical angles. The third point is the slowing the process, right? So two vertical angles has to be observed for computing the distance. It involves more computations for reducing distance and elevation. During the interval of observing vertical angles, the instrument might get disturbed unnoticed. So this may increase the inaccuracy of the process. Due to the above disadvantage, tangential method is considered inferior to the stadia method and is generally not adopted. The most common method of tachymetry is a fixed hair stadia method using a staff held vertical, right? So this is the problem. A surveyor wishes to obtain the height of his instrument by observing a staff held above a benchmark. The staff is held over a benchmark. This diagram you need to draw. They won't give upon the benchmark, which is at a lower level than the instrument. So from the instrument, the benchmark is at lower level. He takes two observations on the staff reading being 3.260 and 1.090. So from here we can see this reading will be 3.26, this will be 1.09, and the corresponding angles of depression being, so since they have given depression, they did not denoted minus. If they are not giving depression and put minus also, you have to remember it is depression, right? So this is 9 degree 36 minutes, 10 degree 48 minutes, right? Calculate the elevation of the instrument if that of benchmark is, this benchmark value is 85.658 meter. We need to calculate the RL of the station A. Obviously from the line of sight to the top reading is V, you know, right? So here H is equal to S by tan alpha 2 minus tan alpha 1, the formula you know. So here S is the difference between the two readings, gives 3.26 minus 1.09 is equal to 2.17 meter, and alpha 2 and alpha 1 are given. H is equal to, then S you can substitute 2.17, tan alpha 2 is 10 degree 48 minutes and alpha 1 is 9 degree. So from that you will obtain the value of H is equal to 100.36 meter, and you know the formula for V is equal to H tan alpha 1. So H you know, now you have calculated into tan alpha 1. So if you substitute all the values and calculate 16.97 meter, therefore RL of A is equal to RL of benchmark plus reading of upper mark plus V. How it is? See, benchmark plus the upper mark reading plus V, that gives the RL of A, right? If they have given the height of the instrument, if you reduce the exact ground point R also you may get. If they are not given, you can stop here itself, right? So substitute all the values, you will get the RL of the instrument axis 105.888 meter, right? Next problem, two observations are taken upon vertical staff by means of a theodolite. The reduced level of the Trunian axis of which is 154.3 meter. In the case of the first observation, the line of sight is directed to give staff reading of 1 meter and the angle of elevation as 4 degree for 58 minutes. In the second observation, the staff reading is 3.5 meter and the angle of elevation is 5 degree 44 minutes. Compute the RL of the staff station and its horizontal distance from the instrument. So here also both the angle are at elevation. In the previous problem we have seen both the angle at depression, right? So you need to draw the diagram. Say they have given 1 meter and 3.5 meter. 1 meter is theta 1, theta 2, right? Similarly the same formula you can adapt. So S is equal to 3.5 minus 1 is equal to 2.5 meter. Alpha 1 is 4 degree 58 minutes and alpha 2 is 5 degree 44 minutes. If you substitute all the things, you will get the value of D is equal to 185.20 meter. And you know V is equal to D tan alpha 1. If you substitute that D is equal to here, you will get the value of V is equal to 16.09 meter. And then the RL of B is equal to RL of the true neon axis is given plus 16.09 minus 1 point. What is that formula represent? See, we required the RL of B. This RL of B is required from, they have given the RL of true neon axis, means here up to this the value is given. From here you have to plus V minus this bottom reading gives the RL of B, right? So that is what we have made. So 169.39 meter. And the last problem, the vertical angles of vanes fixed at 0.5 meter and 3.5 meter above the foot of the staff held vertically at a point where plus 2 degree 30 minutes and 4 degree 12 minutes respectively. Find the horizontal distance and the RL of the point if the level of the instrument axis is 125.35 meter above. D is equal to horizontal distance and S is equal to, you can get 3.5 minus 0.5, you will get 3 meter, right? So the D is equal to 3 by tan 4 degree 12 minutes by here it is 20 degree 30 minutes. So you substitute 20 degree 30 minutes, you will get 100.76. Then the RL of the point is equal to instrument axis plus D, that is V value minus the bottom reading, you will get the thing, right? So I hope you understood the entire concept of stadia method and tangential method and formula to be used for the different methodology, right? Thank you, friends.